Well, one thing I can start by saying, it's quite daring to be in this session. And yeah, I will try not to disappoint and make sure that you made the right choice coming here. Yeah, so I can start by preparing you, warning you that I might be very provocative. And one thing for sure is nothing that I present is dogma. So you are very welcome to challenge it or saying, okay, that is absolutely irrelevant, etc., etc. But this is the take which I think takes us a step forward. But I just want to start by going backwards. How did this all started, or put pieces together so you can see where I am going. So my boy and I started karate 2 years ago, and on our way to karate, he came up with something extraordinary for a 5 years old. He said, "Dad, how do you make an enemy? How do you make an enemy come to be on your side?" And I go like, I don't know, Mario. How do you make an enemy join your side? And he says, simple. You make him or her your friend. And I go like, what? Where did he get this wisdom? And of course, after a period of time, I discovered that his wisdom and brilliancy came from Ninjago, a cartoon where a sensei was trying to teach his apprentice how to not always battle through, but sometimes you can change what I call the dragons into unicorns. Like, so with that connection came this beautiful quotes from this movie called How to Train Your Dragon. It says this is how usually most things happen, right? Most people are afraid of things because they do not understand them. For me, it was a dragon. Then one day that changed, and my greatest fear became my greatest enemy. And this is how the story begins. The biggest issue we are seeing at the moment, and not the issues, but that we are having fences like GDPR, like ALTAI, is some of those things that are popping up, they are actually due to reason that we really don't understand. And I think sometimes we don't understand each other, sometimes maybe we don't understand the models, but I think it's time to start putting things together. And when you look at this movie, it's about a dragon. This boy did not understand the dragons. The Viking always were killing the dragons and the dragon killing the Vikings until something magical happened. If you have seen that movie, you will know what it is, but I shouldn't give you a spoiler. If you want to go watch it, it's such a good movie. So in our context, it could be our dragon is AI and imaging technology. And as a data scientist or a data analyst, when GDPR was introduced, that became my dragon, right? And then just a few years ago or a few months ago, assessment list for Trustworthy AI has been put in place. Right, so the data science industry is almost becoming similar to the medical industry. So everything that we do undergo really scrutiny, and of course we know what is at stake. At the moment, we know what is at stake, right? Because we look in the movies, we read in the magazine, and we see some scandals about AI. You discover that, I think recently, Zillow has been they were trying to predict house marketing, and now they're in a scandal, right? There was a time where we had algorithm that usually predicted well the white male over the black, and that created a scandal. So when we are working with machine, the cost of making a mess is really high. And that's why we come into this pool of saying, oh, we need model explainability, we need model transparency, we need A, B, and C. And yes, we do need that, and then I will come to that. And in my presentation, I will argue that you actually don't need the model interpretability, or you don't need to explain everything in order to fulfill all this requirement. Because at the end of the day, we are trying to build models that are good for our society, are good for our business, are good for bringing us forward. And then at the same time, we're in this battle of having these dragons, being GDPR, being emerging technology, being this new assessment list for Trustworthy AI. Whatever the dragon is, how do we move from having a dragon to a unicorn? How do we change our enemy into our camp? And then, of course, enemy seems to be like a heavy word, so take it lightly. What I just mean was, how do we take the challenging situation and make it best in our progress towards what we're trying to achieve? So every time we've been scared about, oh, you cannot build a model that we cannot explain. Why? Because it will be against GDPR, or it will be against this rule. And my question is that true? Is there other ways to be able to do exactly the same thing, achieving the same results, without having to see this model, how it's performing? So let me take forward. One thing I can say for sure is that we are in this mess, data scientists, because of we started the whole journey of AI and machine learning in the wrong direction. What I say it is in the wrong direction is because when we are training new data scientists, or when we are trying to go and catch up with this technology, we have set goals which we are not supposed to be there. For example, when we're training a data scientist, if you go to places like Kaggle, etc., we are training data scientists to focus on the wrong metrics. So one of the metrics which most of us usually do as a data scientist, we usually focus on something like model performance. I need to train the best model possible. And if you know about Kaggle, it's a place where data scientists go compete in solving different problems. The best model is the highest performing model. So when data scientists comes into the industry, their main focus is building the most performing model. And then after that, they will move to explainability of those models. And there you have this, I usually say, mumbo jumbo of model interpretability and feature impotency, which I will argue they are all BS. I know it's tough to take that one. And then some data scientists will take this extra step of going to the fairness, of saying, is my model fair? But as I put it in a bracket, because most of the story usually end a good performing model that I can interpret, maybe using feature impotency or whatever. And the policymakers have also gave that kind of, I kind of want to say an illusion, whereby if you can explain your model, if you can interpret your model, then we can say your model is fair, or is trustworthy. And I go like, BS. I can have a model that is completely transparent, completely explainable, but highly biased. So having a model that is interpretable and we can explain the features does not necessarily take you to the fairness of the model. So in the same case, I can have a black box model that performs exactly good and extraordinary, non-bias. Why can't I not have that? And I usually paint an example here. So I don't have any painter to paint, but maybe you can just visualize this. So visualize, we have this water container somewhere upstairs, and this container is all transparent. So we know we can make a hole in this container to see how the water flows. And we make the hole up there, and we can see the pressure of the water falling this way. We make another hole down here, and we can see the water either shooting more forward due to pressure. Oh, yes, we can explain how the water flow because this container is completely black. Completely transparent. And it says, well, I come with my spray, dark spray, and spray all this container completely black. And then we repeat the same procedure of making holes to see how the water falls. By me just making this container all dark suddenly change the fact that we cannot explain how the water pressure works? So I argue that we don't need to see the mechanism of things inside in order for us to deduce what the models are doing. We just need to find a way to be able to we have to find another way to be able to inform people how our models are working. Whether we can tell them how the features are performing or not, that seems to be irrelevant. And why did I argue that it's irrelevant? I say, one, feature importancy is irrelevant in most cases because it's dependent on the models we're using. So if you use one model and use another model, you'll have different features importancy. So which feature importance should we trust and which one should we put forward or not? Now, I'm not arguing do not perform all this all these circus of finding the feature importance. Yes, we should do that, but they don't take us anywhere. So it's a talk within the data science team to figure out what's the feature importance, what it is, but it's not for policymaker, it's not for GDPR, it's not for ALTAI, it's not for stakeholders, because it really doesn't matter. When I choose one model, it will give me this kind of information. When I take another model, it will give me another part of information. And I also argue, what will it do for me to give this feature importance to a stakeholder? So here it comes. Hey, we have give you more premium over the other person because location A you're living is 0.578 in feature importance. How does that help him? Right? So it seems like this all tug of war was it was put in a misplace of saying, okay, so if I change to a different model, I get different features or different way of explaining, then it seems it's irrelevant. It seems we are missing a matter, going beyond something in order to have an explanation that is independent of whatever things are in this box. And there comes the answer which I'm going to propose, called the counter-factual explanations. And I will show why, by using counter-factual explanation, you can have any models, white box or black box, and yet be able to fulfill everything GDPR wants, everything ALTAI wants, everything that we all want at the end of the day. But let's take a step backwards of saying we made a mess because we trained data scientists to focus on the wrong metrics. Maybe we can reverse and say our competitions, our metrics of better model should start with models that we can perform counterfactual fairness. So we start with fairness and then move to performance. And I put explainability in bracket because if you can see there, it's a Python code says replace explainability with nothing. Probably we need something even better than that. Right? Are you still with me? So the first thing is we have, as data scientists, we have to start making things right. We have to start calling spades spade. But what does that mean by calling things the right way? Because whenever we talk about machine learning or AI, we have been mystifying them. right? So now it's time for us to demystify them. So when I talk about machine learning, I can simply say this is mathematical representation of data. Whatever garbage data you have is the garbage model you will get out. So there is no magical things happening here. It being supervised learning, where I have the labels, it being unsupervised learning, even it being reinforcement learning. Because in reinforcement learning, we still decide the objectives. So the model can figure a better strategy that I did not know of, but in the end, it still solves the objective that I told it to solve, like winning a chess game. So all in all, at the end of the day, machine learning or reinforcement learning is nothing as the representation of our data. Why does this help us? So this usually helps us when we are in a situation whereby we have a model out there, and if you've watched a Netflix series called Bias in the Code, where this black woman discovered that she could not be found in a facial recognition unless she put a white mask on. And everybody goes like, whoa, data scientists are sneaky. They have done something very bad. They have trained. But I go like, no. You could say that they have trained in a data set that contain white male with very less black women. Oh, we shouldn't panic. We should go back and retrain our model, include the black women, and voila, we are all moving forward. There's nothing magical. And also this is where we as data scientists need to start calling spade by telling the public that my model is a simple representation of the data that I have. Then we are moving to the right direction, the direction where it's going to be easy for us to start doing these counterfactual explanations. So let's go forward. So as you can see, here I said, when we are dealing with this, we have the two kind of questions. We have the, can we trust the model, which this is still in the sphere of machine learning and statistics. And then we have this, is our model fair, right? And mostly when it comes to GDPR and everyone, they really care less about can we trust the model per se. They are more interested in, are the model fair? Are the model performing the thing that they're supposed to do? Whether we know the mechanism of them or not, it seems to be irrelevant for the policymaker, for the people who are affected by our models. And another case I also make against this feature explainability and transparency is that in most cases, we actually do not have, we cannot do that. It's not feasible for us to give you an explanation from the model that, well, you come and says, so imagine that we're an insurance company and the assumption was that GDPR gives the insurer permission to ask, how did you score me? How did you come to this conclusion? Why did you raise the premium? And then the insurance company has to call the data scientist, hey, go to this model. It shouldn't be a black box because we need to see the mechanism inside so you can explain to the person how did we score them in the end of the day. Show them the logic. So in this case, I remember when I was working in insurance, we couldn't use deep learning models. Why? Oh, because everybody thought they were black box and nobody wanted to go to that area. And in the end, I go like, no, actually, we can go to that area. Because in the end, even by trying to tell you how the model scores you, I'm actually have to be GDPR incompliant to be GDPR compliant. How? Because the moment I try to show you about your data, I have to show the data of other people too. Because in most cases, we don't have an individual data. Like our data are what we call, they are collective. So an example is your DNA. You can give consent for your DNA, but your DNA carry everyone else that brought you into being. So their DNA is also exposed. So by me wanting the information of my DNA is actually asking the DNA of other people. By me giving consent of the pictures, what about all those people around me? So there is nothing individual in data, because most of the time our data is collective. So in this case, I go like, one, you have to be kind of GDPR and compliant, to be GDPR compliant by showing somebody this data, by unmasking this model. And two, where is the competitive advantage in that between two insurance companies? If one can call that, hey, insurance company, how did you score this guy? What stopped the other company from copying the metrics of this company to also score their customers? Where is the competitive advantage in that? So in the end, we were in the situation where we have to rethink everything, because this does not take anywhere. Is there possible for us to have closed models that we don't have to see what's going inside, but yet fulfill GDPR, ALTAI, and everything else? So that's where I'm trying to, this is the message that I'm trying to sell you, that yes, you can actually change our dragons into unicorns without poking inside. So here comes the counterfactual explanations, and I will just actually run you some demos here, because we are in. So here I'm going to run some demos. So right now, oh, sorry, it's not Python, but PyTest, the cost of doing live demos. So I'm just going to clear that. So I will bring you into a real example. So while I'm talking, the codes, the test will be passing, and these are actually real tests. So how did we overcome this problem when we got a new project? And this project was one of the most sensitive projects, because we were working together with Barnes Vilko, the children welfare. So we were dealing with children data. Whoa, we knew we were going to be in trouble. We knew the moment you said we are using AI with children information, the world will blow into pieces. And yes, it did blow into pieces, but we came out in the bright side. Why? From the beginning of the project, we decided what kind of actions were we going to take to ensure that we can have whatever models that we want, but yet fulfill every single, not every single details, but every possible questions or concern that we were going to have. And we actually started fulfilling this before the ALTAI came out, the assessment list for ethical AI, trustworthy AI. And even when that came, we had already fulfilled those requirements. But how did we go about? So here's where I will start wrapping things up by showing you how we went about doing that. One, we ensure that all our contributor had to pledge, had to set a pledge on what are we going to do. We're going to follow some ethical guidelines. So when you come and contribute in this project, we did two things. When you contribute, because we're using Git, we know who has committed, who has made what change, etc., etc. But on top of that, because we know we can mess up with our Git history, we can go and change what has happened on your history, we had to find a way where we can freeze whatever changes. So a blockchain technology, in order that whatever has happened is captured into this block. So you can change your Git history, but you cannot change this block. And whenever something else comes, we add it on that block, on top of that block. And now, after creating this kind of ledger, we can distribute this ledger within the developers and also within the stakeholders. And you will ask, why the stakeholders, right? And I will come to that. So the first thing is, we say we're going to follow a certain kind of guidelines. And if you're going to contribute to this project, you will follow these guidelines. So we expect you to do that. And the moment you commit, your commit and your acceptance goes to the blockchain kind of flow, a ledger that will keep you accountable. Why did we go that way? Because we knew you could go back and change your Git history. And we did that to be possible. So you can change your Git history, but you cannot change the ledger. So once you have done something, we hold you completely accountable. So that's one. So what are these ethical guidelines, right? So I will just jump here. And then I'll do a preview. So one of the things is the classical ones, right? The data collection. So whenever we receive data, we go like, okay, yes, we have received data. Then we ask the client, were the people informed that we collected their data? Were they informed that we're going to be using this kind of data analysis on their information? Yes, they did, and they did that. And this now comes to the blockchain technology, because this part they had to answer. So we created an endpoint which, when they answer yes, we store that in the chain too, in our ledger. So we can go back and hold them accountable, that you said you have done your part. So when we do our part, we record it. When they do their part, we record it. So in the end, when there comes a third party who is going to audit us, he can see both sides, what are they doing, right? And after that, it's all this, how do we store data? How is it right to be forgotten? Everything that GDPR wants. But the most important part comes here. So all these other things, probably you're very aware, this is the most important part. So how do we ensure fairness through an awareness? Like, because we know that there are some kind of protected attribute, sex, ethnicity, gender. How do we ensure that our models are passing this kind of test? And here comes our counterfactual fairness. So we build a pipeline to which, so how does counterfactual fairness play? A counterfactual fairness plays like this. We have a model and we perform those tests. So we make a hole here and we see how the water falls. We make another hole here and we see how the water falls, right? So in this case, we say that our model is not affected by gender. So how do we create a counterfactual way to test that? So a counterfactual is you keep everything the same and you change just one element. So we pass the same sentence as, I think I have some test here. So you, sorry for non-Danish speaking. So you can see when it comes to something like religion, we pass the same sentence. Abortion, I am a Muslim girl and want to do something. Abortion, I'm a Christian girl and want to do something. So you can see the only counter thing that changed is religion. And this then is passed through the model. Do we receive the same scores? So exactly as we make a hole here, we see the water coming here, we make a hole here, we see the water come down there, right? So it doesn't really matter what kind of model is running there. Are they giving the same result given same circumstances which we together with stakeholders agreed? So another part is gender, right? So we check gender, we check age, we check sexuality, we check all those things as counter example which goes to the model. And if your model passes the counterfactual test, what else is there we're going for? Now, here comes a journalist and says, yes, you're saying that you're performing this, you're performing that. Should I just take your word for it? And I go like, no, don't take my word for it. Here is an endpoint, which we're going to spin up a session for you and hammer our models with all other counterfactual cases that we are not aware of. Maybe you're going to find a hole. And if you do find a missing factor, then we go back and add that into our tests. And this test now become part of our continuous integration. CI/CD, continuous integration and development. So whenever we build a new model, this model will never see production until it passes through our tests, whatever that model be. Black box, white box, who cares? Because at the end of the day, that's what is important. Do you agree with me? I know it's a bit hard to swallow. But then I always rewind back and says, we are not saying you shouldn't do model interpretability and all the things. Those things are cool in themselves, but they are not for the outside world. They are not for stakeholders. They are not for people we are trying to score. They are mostly for data scientists within us. But they are not anything that take us to the next step of saying now our models are fair. So we can fulfill GDPR, we can fulfill the assessment list of Trustworthy AI, because if I have a model that we can always trust its output, then I really don't care the mechanism that happens inside. And hopefully, by the end of this talk, you will also come to an agreement that that should be the case. Because in this way we can answer GDPR. In this way we can answer the assessment list. We can show that the protected attribute does not affect our models. And even though, here I come to another, because I like swallowing the big questions. What if it did affect our models? Should we then just back off? And I says, no, not really, because I came to a situation where people were building models and they were scared that, oh, there's a feature of foreigners. It was about scoring the house prices in Denmark. And one of the data sets says the number of foreigners in this area. So apparently, which is true, when there's more foreigners, the houses are a bit lower than when it's non-foreigners. So the question is, should we remove that attribute, as sensitive as it is, so that we can comply to an ethical model? And I say, no. Because even myself, when I want to buy a house, probably I will look at that, because that's the world as it is. So there's a world as we want to be, which is, hopefully it's coming, and there's a world that is as it is, right? So what do we do then when we have a feature that we know is protected? I go like, as data scientists, we come clean. We come clean and says, we know that we have this feature that will create this issue. So we come really at the first post, we say, our models are saying that the number of foreigners in this one are creating this kind of model imbalance. Should we remove it? Maybe not, because that's how the houses are valued there. But what do we need to do? We need to make sure that that attribute is put in the front. The moment you come to look at my model, you read that as the first big letters, that we have kept this because of A, B, C, D. And we take a dialogue from there. But just tossing something because it's scary, it's a bit interesting, because I says there's a world that we want to be and the world that we are in. And the world that we're in, we should just come clean and says all our models are simply a representation of our data. And if we come with that, then we can have a dialogue on how to make our data better, and not so much about the models, right? And then from there, we can also know how to test these models. And so coming to conclusions, I know that we have to start doing something now. We need to start changing the mindset on how we present things. We need to start calling the spade. We need to start doing this model explainability in a way that is accessible to stakeholders, to ordinary people. Yes, we should keep the interpretability and feature importancy, whatever that is, within us data scientists. But outside there, like with GDPR, that's not what they're going for. I think they're going for the fairness, the trustability, the traceability. And if we can fulfill that, we can keep our black box models, right? So we have to do, I said that we were supposed to have done this yesterday. But we are here today. But it's still not too late. And of course, we are all doing this for the future of our kids and the next generation after us. Well, with that, I say thank you. And I have actually Shanoza here. She has been working in this project together with me, and she just wanted to share how is it to work in a framework like this that ensure that people do not, like how is it to work in a frame where we build pipeline to ensure that data scientists can be data scientists without worrying about everything else.
Yes, thank you, Prayson.
Yeah, I think, yeah, I can try.
Yes. Good. Thank you, Prayson. So I'm a data scientist in the team in entity data, and I will share the experience. How is it to work when we have this kind of CI/CD pipeline setup that has incorporated ethical guidelines? So first of all, when you start in the project, you feel accountable, of course. You know that every of your step is being registered, and better you know who has access to data and which developer has access to data when. You can, of course, see it on a Git history, but more importantly, you can see it in the ledgers. It adds accountability. But you also know that every peer developer that is working in that project has signed it, has pledged to the ethical guidelines, which means that which means that you have clear guidelines that you have agreed with the stakeholders. You just have to follow those guidelines, those ethical guidelines, and you have to act upon it. You don't have to think, which kind of ethical test I should come up with myself, but you just get those guidelines that have been agreed with stakeholders and keep being updated, and you just write your test and then act upon that. And the second thing is you can be a data scientist. You can focus on the things that you do most, you do the best. You can focus on the modeling, you can focus on building the tools, and you always know that you're protected by safety net, that you cannot push your messy code to the code base. You cannot mess up. Even if you mess up, your code will be caught with pre-hooks and tests. So you know whenever you code, you're following the ethical guidelines by default. And the third, you can have a clean conscience, because you're not the sneaky data scientist anymore. You have done your job good, you have followed your ethical guidelines. You know that whenever there will be third-party audition, you can clearly say, I have did all the process and I have followed everything and I know what I'm doing, I'm clean. And I think the most important of all, that you can be calm and sleep quietly, that knowing that you're contributing to the better future.
Yeah.
Thank you.
Thank you, Shanoza.